I want to welcome everyone here to this. Can everyone see my screen, first of all?
Yes.
Yes, we
Properly,
can.
yes. Okay, perfect. I want to welcome you all to this first exploitation workshop of the EnerMan project. We are a mix here of people from the stakeholder community and from the internal project partners, and it's really nice to meet you all like this. So to introduce myself, my name is Stina. I'm working I'm an intern currently at the Supply Chain Innovation Department at Infineon Technologies. I have a bachelor in chemical engineering and engineering physics from Chalmers University of Technologies in Gothenburg, Sweden. And I'm currently doing my master's in sustainability and industrial ecology. So for today, and we have some more speakers and people that have worked with this workshop as well, but they will present themselves all throughout. So the workshop agenda for today, there have been some few moderations since last, but overall the same. We will have a welcoming and EnerMan introduction, description of the target and methodology of the workshop, the EnerMan exploitation activities, and an activity regarding energy efficiency and energy efficient management perspective, presentation of the EnerMan KRs, and then a SWOT analysis as an exercise. And for the first, I would want to welcome Alessandro Sanella, the coordinator of EnerMan, to introduce the project.
Okay, here I am. Hello, everybody. I'm Alessandro Zanella from Fiat Research Center. I am the coordinator of the project. Let me make a very short introduction of the project, because later it will be anyway described properly. The project is a European project, started January 2021. It is a project with 22 partners, so it's written 21, but we are 22, in different countries. As you can see, the number of countries is quite relevant. Here are the partners of the project. You can see all of us. Let me say that the partnership is mainly distributed in three main groups, which are more or less usual. The end users, and you see that they are many. Indeed, in the project, there are 8 pilots on which the energy developed technologies will be applied and tested. The technology provider, from integration to software development and other technologies that are needed inside the project, and the research and university with a large and strong group providing innovation technologies to our project. Which is the problem behind and the core ideas, which are the problem behind and the core ideas of the project? Well, first of all, we all know the energy, it's an issue. The industrial sector uses a lot of energy, more or less 54% of the world's total energy is used by factories. 58% of the energy consumption in Europe comes from import in 2020, and we know that this is a strong problem for many reasons, and this is limiting the control over the supply chain. Optimizing and predicting the energy consumption of critical energy consumer like industrial manufacturing, because anyway, Europe industry is at the core, let me say, it's very relevant, can make more efficient and also more strategically controlled somehow, and thus it's really important. What we look at energy sustainability, that we intend to be as energy consumption, energy cost due to the cost of the power supply of the electricity, and CO2 emission, with the aim, of course, to improve all these KPIs. Energy sustainability for us is a strong KPI that we want to have in our management loop, besides time, cost, quality, productivity, and all the other KPIs that are strategical and relevant for the factories. Our idea starts with a static and dynamic energy consumption matrix, coming from measurement to efficiency and models applied. What does the project do? The project works on different levels, from the data collection, and let me say management and CPS at the CPS level, data trends prediction. So the collected data are modeled in order to get a prediction to be able to signal trends to the user in the plant and to suggest and implement changes with different kind of let me say implementation that can come from the operator applying the suggested changes to more autonomous implementation. We have 8 pilots stated at the very beginning, 3 pilots from Centro Ricerche Fiat, which is a research group, which is a research center inside the Stellantis group. Avwell, which is a big Austrian company related to automotive. I think if I say all of them, it gets too long. Anyway, Infineon, semiconductors, Iotis, food industry, and metal manufacturing and processing industry, Asash, Johnson & Johnson, Stomana, and Prima Electro and Prima Additive. All of these will be, I think, slightly described and give us a huge vision and a huge landscape of the possible application target for our project development. As I previously said, very fast, we start from the data collection with the CPS data collection. We optimize the CPS data collection at various levels, from the security level of the CPS to the acquisition strategy, data management, data communication, analyze the data, create the models in order to have a simulation engine on which the pilot will be applied on the pilot. So this is all as a generic introduction of the project. As Tina said, I will also welcome you to this EnerMan stakeholder, and I give the floor to the next speaker.
Okay, thank you very much, Alessandro, for this introduction. I will go back to sharing. Let's see. So then before we move on, we want to ask a sort of interactive questions to the participants here. There is a web-based sort of survey tool called Slido that you can either, I know Abdo can share the link to this in the chat, and you can also use this QR code on your phone. And we will simply ask the question, what are your expectations for this workshop? So you can answer this with a simple 1 or 2 word answer regarding your expectations for this workshop. Great, so we have some exploitation approaches, energy efficiency, project overview, external feedback, to be a partner potentially. Some brainstorming, energy management, exploitation potential. following the technology, dissemination. Tool benefits energy saving. Am I sharing now?
Yeah, no.
Yes.
Yeah. Sorry. So we have this live Q&A, and this is in the same Slido link within another room within the Slido. So there you can ask questions that you may have. Now we move on to the target and methodology of the workshop, and this will be presented by me and Ana Rita Salgado. Rita, do you want to say something about yourself?
Yeah, thank you very much, Tina. So I want to welcome everyone. I'm also, as Tina, an intern, and I'm writing my master thesis at Infineon in the field of carbon accounting. And I study industrial and management engineering. And yeah, today we will start then with the target and methodology.
Thank you. Okay, so of course for this, we come from the sort of exploitation activities from the EnerMan project, and Abdel Ghaffar will in a moment explain more what exploitation is in the sense of the EU-funded Horizon 2020 project, or the 2020 the Horizon 2020. And we wanted to conduct this workshop, of course, to give an opportunity to engage both internal and external stakeholders and partners of the EnerMan in the exploitation activities of the project. So show what has been going on from our side and also give an insight overall into the project. And we have a few buzzwords here, also related to the things you actually said in the interactive part. So it's a lot about feedback, insight and information, networking, ask questions to the partners and the project managers, etc., and then sharing ideas and also working together. So this is a very give and take sort of workshop, and we also wanted to meet in this sort of sense to give a good view into it. And this will, of course, be done then, as said, with exploitation activities, including the strategy, the progress and the steps taken, the ongoing steps and the upcoming steps. We will have some interactive discussions on the importance of energy efficiency. We will get short technical updates from the work packages and also presentations of the key exploitable results. This will be further explained in the workshop. And also an interactive discussion on the SWOT of the EnerMan, so the SWOT analysis of the EnerMan, both regarding already added items that we already have thought about, and also the potential for additional ones as we get a lot of fresh air into the discussions through this workshop, both from internal and external stakeholders and partners. And for this interactive discussion on the SWOT, I just wanted to give the word to Rita to explain and sort of give a recap on what the SWOT is, sort of as a preparation for this exercise. Rita.
Mm-hmm. Thank you, Stina. Yes, so before further discussions, we will shortly recap what consists of a SWOT analysis. So what is a SWOT analysis? It is a matrix that reflects the strengths, weaknesses, opportunities, threats of a business or a project. And on the next slide, we will be able to see a scheme about this as well, that the strengths and weaknesses are considered internal factors in a company, whereas the opportunities and threats are more related to the external environment. Then we will move forward to the purpose of a SWOT analysis. So it can be used by a person or an organization to discover the strengths, weaknesses, opportunities, and threats relevant to business competitiveness or project planning, contributing to a better situational overview and allowing an overall business performance measure. And finally, how did we proceed in EnerMan's specific case? So after a preliminary SWOT analysis, which was done right at the beginning, The refined one was made through the support of online surveys answered by the different work package members. Yes, we can move forward. Yeah, so you can see here that the strengths and weaknesses have an internal origin and the opportunities and threats have an external one, as I mentioned.
Great. Thank you. And also the SWOT analysis that we've already sort of conducted as a start will also be presented further on. So you'll see the ideas created previously by us together with a consortium. Thank you, Rita. With this, I want to give the word to Abdel Ghaffar for the EnerMan exploitation activities.
Thank you so much, Stina. A warm welcome also from my side to all the consortium partners, also the stakeholders in this first exploitation workshop of EnerMan. We aim through this workshop, as Stina and Rita mentioned, for a feedback-oriented and interactive workshop. In this presentation, I would like to present you the EnerMan exploitation activities. Here, we started these activities back in month 12 by presenting to the consortium our strategy, and then we met in the kickoff to see how to execute it and who will also take part in the execution of the exploitation activities. If we move to the next slide, just the previous slide is a reminder again for the live Q&A, which you can use always to post questions about the workshop or about the exploitation activities or about EnerMan. Okay, Stina, do I need to activate the slide to Q&A or it's already active?
No, it should be fine. It should be activated.
Okay. Good. This slide shows the structure of the work packages of the EnerMan project, starting from work package 1, which is the baseline of the project, where the requirements, the use cases, and the architecture and specification of the project are laid out. Here, also end-user driven requirements are defined. Project setup and positioning is provided. Then we move to work package 2, the data collection control plane design, and work package 3, the EnerMan industrial management system. Work package 4, the system analysis and prediction. You probably remember these 3 planes of EnerMan. These 3 technical work packages also visualize and depict these planes. We'll see these 3 planes a lot through these slides today, because they also represent, from our point of view of the exploitation, they represent the key exploitable results, the main key exploitable results of the EnerMan project. Then we have the work package 5, which is about the integration and cross-layer optimization. Together with work package 6, also an integration, small-scale trials and validation in industrial settings. Here we see the validation and the demonstration of the project outcome. We have the work package 8, which is the project management of EnerMan. Work package 7 is about the communication, the dissemination, and the exploitation. In the next slide, we see distinction between communication, dissemination, and exploitation, just to clear some ambiguity about these terms. Communication is when we inform, promote, and communicate the actions and the activities and the results. Dissemination is when we make the results and knowledge public and open for others to use. The exploitation is making concrete use of results for commercial, societal, or political purposes. One more slide in the next is to distinguish or to differentiate between dissemination and exploitation. Both are about facilitation and the facilitation of the results of a project. From one hand, the dissemination acts as a tool to make results available by means of scientific publications, for instance, or policy brief, roadmaps, trainings, demonstration, you name it. From the other hand, exploitation is a tool to make use of results, and this could be in form of spin-offs or startups, products, patents, standards that are um, obtained from the outcomes of the project. Moving next. Um, so why we do this exploitation for EnerMan, namely because we want to ensure the long-term sustainability of EnerMan, even beyond the project frame, and to ensure that this EnerMan model is a living system, which is constantly updated with new sets of data and adapted to the Industry 4.0 trends. And for who? When we talk about exploitation, we talk about stakeholders, besides also the consortium of EnerMan. This could be the pilots, different industries, SMEs, or researchers, and those that can make good use of the results of EnerMan, like authorities, policymakers, and especially about policy making. We will have an activity. It's an icebreaker activity, which I will come to in the next section of the workshop, to see how climate policies based on energy efficiency will have which kind of impact on the climate change fight. Okay, then how? Um, the final aim of the EnerMan exploitation activities is to produce market surveys, and these market surveys will be characterized by first involving all partners and also stakeholders like vendors, potential production partners, and service providers. And also these market surveys need to consider all the activities that has been done so far in the EnerMan tasks. I think we talk about integration of all the work packages, and here we also in the exploitation activities, we need to act like one consortium and making use of all the results that emerge from the other work packages. Then coming to the next slide, this shows briefly what the task 7.4 is about. Its aim, which I mentioned in the previous slide, who is acting in the task 7.4. Infineon is leading, and we have participants from all the consortium. We started in, the officially start is month 13, but we started in month 12 with the preparation of the first exploitation report, which I will talk about in the next slides. The exploitation activities will continue throughout the lifetime of the project of EnerMan, because most of these concepts that we will discuss today, like the KER, like the SWOT, they are living things. They change and evolve and need to be refined and updated throughout the lifetime of the project. Just one more point to mention: these exploitation plans and market surveys that we will produce throughout the task 7.4 will focus on consortium-wise exploitation, as well as individual exploitation. I think here the reviewers on the review mentioned that we need to focus on the consortium-wise exploitation and maybe focus on it on our exploitation activities and describe it even more, make it even clearer. Interact and STS will help in the individual exploitation by providing a business-oriented exploitation plan. From our side, as Infineon as leading of the task 7.4, we will help in the identification of the exploitable project results together with Interact, which will help in the IPR protection mechanisms. Next, I come to the strategy broken down into the actual activities that we are doing since the start of the task. We have been having regular meetings to update the exploitation strategy and to track the progress of it. Exploitation workshops is part of the strategy. This is the first one, which is it's taking place virtually. I hope the next one will take place in person. You will see in the next slides that the next one is planned for next year in July 2023. Hopefully, if there are no COVID restrictions, we will see how to plan it in person to bring all the consortium together and act as one consortium. Then we talked about involving the partners, either the consortium or the stakeholders in the exploitation activities. This we are doing by surveying. We surveyed people already about the key exploitable results, about the SWOT analysis, and we have a long list of analysis that we want to achieve, like the Kano model analysis or the business model canvas. We also want to inform all the partners and the stakeholders about our progress. This will happen by means of newsletters, website updates. We're already creating brochures to document the results of the surveys that we had with the partners. We are also active in relevant events and relevant European projects. Here we get the help of Interact to name some sister projects from the European funded projects. Moving next to the next slide. I hear some noise. Would be great if the person could mute themselves. This shows the timeline of the exploitation activities. We started, as I said, in month 12 with the delivery of the first exploitable result, first exploitable report. Then we had the kickoff in month 13. We delivered the first stakeholders engagement report in month 18. Today, we are in the first exploitable workshop. We'll have the final exploitation report due in month 24, the end of this year. The next workshop, second workshop, is going to take place in July 2023. I hope it will be organized or take place in person, as I said. Then we have the final stockholders engagement report. There are discussions currently about moving the leadership of these reports to Interact, since they have more relationship to the stakeholders activities which Interact is doing. We will update this timeline if this amendment happens officially. Okay, then moving next. Here shows this list of deliverables. The first two, the D7.6 and the D7.9, are already successfully submitted. As mentioned, we have two more deliverables. One is the second exploitable report due in month 24, and D7.17, the stakeholders engagement final report. If it's going to still be led by Infineon, we submit it. If it's shifted to Interact, then we update this list. Okay, I move next to a quick summary of the EnerMan communication activities and stakeholders engagement first report. This deliverables gives an overview of all the EnerMan communication activities and stakeholders engagement activities held in the EnerMan project. The document includes the result of a survey and a stakeholder analysis, which describes the most significant stakeholders within and around the EnerMan, especially the EnerMan value chain, and states their position to set up engagement strategies. And the stakeholder analysis helped us to see how stakeholders are familiar with energy production patterns and trends, and as well as the energy market trends. And however, the level of expertise differ between the stakeholder roles. Stakeholders have positive attitudes towards the transition to energy efficiency and sustainability measures. Finally, the stakeholders indicate knowledge providers as the organization they most often collaborate with. Moving next, here I give an overview of the first exploitation report, which was about the business models and the market analysis. Here we showed the exploitation strategy, we show its timeline, and we provided a preliminary analysis of the key exploitable results, a preliminary market research. We showed also the SWOT analysis and our plan to enlarge it and extend it together with the consortium and external stakeholders. Moving next, here we see the main key exploitable results of EnerMan that we analyzed. These are basically inspired by the three planes of EnerMan. We have the EnerMan Industrial Data Collection System, EnerMan Energy Digital Twin or Energy Aware Digital Twin System, the EnerMan Production Management System. These key ERs could either be exploited individually or as one main or one whole EnerMan package solution. Then moving next, also part of the first exploitation report, we provided a preliminary market analysis. First for the EnerMan Industrial Data Collection System, where we look at the exploitable outcomes of the industrial data collection system, like the cyber physical system, the CPS, or the IoT, or the artificial intelligence. For the cyber physical system, for instance, we saw what is the estimated worth of this CPS. For instance, it's predicted in 2028 that this will grow by 10%, 10.5 or 10.55%. We also looked at what are the companies that are leading in this technology and what's their market value and their market share. We did the same for the IoT, the industrial IoT, the companies that are leading, the market value, the market share. The same also for artificial intelligence. What are the leading companies? What is the market value and the market share? This, I think, help us to identify the market trends and the dynamics in the market where the EnerMan exploitable results will need to compete, or they will need to also gain competitive advantage. Moving next, also to
Abdul, just for the time constraints, I think we need to keep this a bit shorter, this part on the market analysis.
Yeah, I think the next slides I will go through very, very briefly. It's for those who are interested to look at in-depth view of these. This is present in the first exploitation report. It's market and value analysis of the three exploitable results of EnerMan, like the digital twin, like the industrial data collection system, and the production management system. Market view or market research will help us to identify the trends and the dynamics of the market. On the other hand, the value network analysis will help us to identify the competitive ecosystem. And I think this is also was a comment and a wish coming from Benoit, from the reviewers, who asked specifically to include this competitive ecosystem as part of our exploitation activities. Yeah, I think this concludes then my part related to the exploitation first report. Um, Now coming here, what is going to be included in the final exploitation report is to continue this analysis of key ERs, SWOT, business model canvas, and to use this as a foundation for the consortium-wise and the joint exploitation plans. We are in continuous refinement of these. Right after the August vacations, we will conduct interviews with technical work packages about the business model canvas. The aim of this is, as I said before, even if this business model canvas already exists in the grant agreement, we think due to the changes in the external factors, in geopolitical reasons, these aspects, the business model canvas, SWOT, and all these aspects need to be continuously updated. Okay. How much time I have?
None really.
Okay, then I think
Yeah.
this I already briefly talked
Yeah.
about the different analysis that we still have as next steps to do until the final exploitation report, the Kano model analysis, the other analysis, which I all talked about briefly in the previous slides.
Yes. Okay, thank you very much, Abdul. Do we have any questions on this or any input from the Q&A? And as Abdul mentioned, this can also be more, the first exploitation report is also a more in-depth version of this presentation. Abdul, is there anything in the Q&A that you see?
No questions in the Q&A.
Okay. Okay, great. Then we move on. We will move on now to the energy efficient management perspective part. This is also led by Abdul. Yeah, I'll let you go and present.
Okay, thank you so much, Stina. Here we wanted to have an icebreaker activity where you could see the impact of energy efficient management policies on a global level. If you move to the next slide, again, a reminder of posting your questions in the live Q&A. And here, what are the key learnings from this icebreaker activity that we will do all together? It's like we travel in the future, time travel to the future, where you see after the outcome of EnerMan and the results of EnerMan, when they are used on a global scale, how it's going to be their impact on climate change tackle. And we will do that with a live demo. I will come to the tool which we will use. Then you will see the impact of energy efficiency policies on the reduction of energy demand. We will evaluate other scenarios to reach targets of climate change fight, like the targets of Paris Agreement. The time travel machine which we will use is a simulation tool which is called Inroads. And I think I need to present from my side to show you a live demo of this tool.
Yes, I'll stop sharing.
Okay. Okay. So this is simulator called Inroads, which is built by the MIT School of Management. It's free and open source software. The underlying technology used to build this is system dynamics, and system dynamics allow this system thinking of how policies interact with each other to make impact on complex systems like the climate. Here, what you see graphs like the one related to the global sources of primary energy. We have the different energy sources we use globally, like the coal, oil, gas, renewables, bioenergy, and nuclear. The use of this energy is related to greenhouse gas emissions. Today in the world, we emit around about 60 gigatons of CO2 every year. It's also expected to rise because of the economic activities and the rise in population and the improvement of quality of life as well. These emissions of greenhouse gases will contribute to the global warming and to the rise of temperature worldwide. And these days, you can also experience it yourself with the heat waves that is hitting Europe. But it's expected by the end of the century that the temperature rise will be plus 3.6 degrees Celsius. This relative temperature is compared to the pre-industrial levels. We also have sliders, which by moving them left and right, you can implement a climate policy to change this temperature rise. We have energy supplies. You can, for instance, tax fossil fuels because fossil fuels are still cheap, even if even or despite the increase of fossil fuels because they don't reflect the impact they make to the climate. We have other resources or sources of energy like renewables, nuclear, or if there's any new zero carbon technologies. Carbon price is also part of the policies you can make. We have some sectors which you can apply policies like the transportation, the buildings and industry. Here we see energy efficiency and energy efficiency in the buildings and industry sector. This is where I think the EnerMan outcome will contribute. We have growth sliders. You can move them left, right. You can slow down economic growth or increase its growth. We have sliders related to the land and industry emissions, carbon removal, because if we reduce the carbon emissions, we still need to remove the carbon which is in the atmosphere. I think that's it what I wanted to show you. Maybe before I move to the activity, which you get to use this tool yourself, I can just give an example of one of the policies. If say that what impact will carbon price have if we price carbon, you could see clearly that the energy demand drop, especially for the carbon-rich fuels like coal, oil, gas, and this, on the other hand, increase the use of renewables because renewables get cheaper compared to fossil fuels. Here I can bring a graph of cost of energy. You see the cost of energy increased dramatically. Um, when you look at the greenhouse gas emissions, you see a drop in that, and you see also a consequent drop in temperature by zero 0.7 degrees Celsius. Okay, so that's what you are going to do in the next 15 minutes. We will split you into two groups where each group will build a climate policy to keep the temperature within 1.5 degrees and 2 degrees Celsius according to the Paris Agreement. Please focus on energy efficiency policies which are related to EnerMan. As I said, 15 minutes to brainstorm, think in a holistic way. When you move a slider, think about what moving this slider will have, which impact it will have on, for instance, industries or households, and so on. After the 15 minutes, you will come to pitch your policy, which you build. We will give each team 5 minutes for that. Okay. Now, please, Nilay, please split people into two randomly.
Yes. Okay, I'm splitting.
And I will be a moderator of one group. Stina will be a moderator of the second group. Please, Stina, use the inroad simulator.
Yeah.
In your group.
Yes.
I will send you the link. I will send it in WebEx, Stina.
Thank you.
Excuse me, you said the link through the Teams meeting because I don't have permissions for messages and I have a problem.
You don't need the tool. Stina will be opening the tool as your moderator of your group.
Okay,
or
great.
me, in case
Okay,
you
thanks.
are in my group, I will be opening the tool, and then you as group member, you think together of a policy, and we change it together in the software.
Okay.
Sorry, I'm trying to make it.
Any thoughts?
The renewables.
Sorry?
The renewables.
Yeah. So there we have, we can subsidize or highly tax them.
So the opposite.
Yeah. We'll do some highly subsidizing then. We're down to 3.3 plus.
Hi, I would also suggest to increase energy efficiency because EnerMan, I mean, in buildings and industry probably, which is the main focus of EnerMan.
Yeah. We highly increase.
Yeah, why not?
That's also, it could also, of course, be a question of what we think is possible within this decennia, but
maybe also the electrification
within buildings and industry.
Yes.
Yeah. So we have incentivized, highly incentivized.
Maybe to reduce the population, but it would be nice.
Yeah. The population reduction is always such a, it's a very tricky one in regards to how. But we can, of course, check, because I think it's very interesting to see if we decrease the population. So the lowest growth, for example, it doesn't, the change it makes isn't that big, actually. In regards to this temperature increase.
Maybe we can reduce some oil supply.
But does this take into account the total energy supply? I mean, if you reduce oil, we don't need to increase something else.
Yes.
Yeah, because this, of course, yeah, sure, go. I interrupted someone. Please go.
Yes, maybe we can increase the new zero carbon or.
What does that mean? What is the new zero carbon?
So the new zero carbon is basically it's a question of breakthroughs with the new zero carbon technologies, and we can look here. So this is some speculate that such breakthrough could be nuclear fusion or thorium-based nuclear fission. So it's more of a what if kind of statement. I think of a lot of things that are currently being researched, but there's no big breakthrough. But I mean, for the coming 100 years, this could, I mean, a lot can happen in 100 years. Do we want to have a breakthrough within new zero carbon?
It's something that it's not sure, so
we'll wait a bit.
Okay.
Okay, so we're at 2.8.
Bioenergy is mature enough.
Yeah. So subsidized bioenergy. We said before taxing oil. Are we all on board this?
Yes.
Any people against? We can tax. Here we can see as well, we can look back at the financial, keeping in mind. So here we have a bit of an increase in energy cost. Still fine. We can also look into how it's subsidized. This is also not that long of a discussion, but I just want to show you as well that they have all these. So you can see reduction in oil utilization. So you can push the reduction further, or reduction in oil utilization stop, etc., etc. So there are a lot of related graphs to this. And you can see here for the oil primary energy demand, since we subsidized, or since we highly taxed it now, the current scenario is way lower than the baseline of what we're currently working with.
So Stina, maybe
Yes.
Can we do something similar for the energy efficiency of buildings and industry?
Yeah.
Check, what parameters we could fine tune.
Yeah, sure. So with energy efficiency of buildings and industry, you have so the highly increased is set as we can even increase it. So it's a 4.9% like improvement per year. This start year is 2022, and the rate of buildings and industry retrofitting at 5% a year. And then for the, I can show you for the electrification, we have electrification in new buildings and industry is then, now we have it at 100% for as a goal, and then the year the electrification of buildings and industry accelerates is set to this current year. So this can also be pushed up maybe in regards to if what is feasible, for example, if we have these ideas. And you could see, for example, for the electrification, whilst pushing it forward a bit, it also decreased somehow somewhat the cost of energy and planed it out a bit towards 2040 to 2080. So regards to how fast the change is, so to say. Yeah. Anyone have any input?
Okay, maybe we would also try tweaking the transport domain.
Yeah. Energy efficiency.
Yeah, to increase it.
We highly increased energy efficiency. We see the sources of primary energy, and the energy use is planed. We'll try increasing electrification in transport. Didn't make big difference. We still have 0.5 degrees within the Paris Agreement. We have what we haven't looked. Sorry?
Yeah, I was gonna say, what about the carbon removal, like the technological? Like what happens? Can we try?
The technological one. Yeah, because now we kind of started with the energy supply, transport, business, industry. We've seen that but we've seen the effects of energy efficiency. So now we can move, because this is also a big
impact.
Yeah. So you have the technological carbon removal, and I think they have examples of, so the CDR, the carbon dioxide removal technologies with direct air capture, bioenergy with carbon capture and storage, biocar and others as a type of carbon removal. So that made a big impact looking forward. We have these natural gas, new zero carbon technology, carbon price. We haven't done anything with yet. Anyone have some insights? for example, increasing the carbon price makes a pretty big difference. Of course, as Abdo mentioned previously, this shows in a huge difference in the cost of energy. You have a very high increase. This carbon price can also be, you can change the year the carbon price phases in. So when it happens, you have the years to achieve the initial carbon price. So how fast it goes, and then the final set carbon price, for example. But you can see as well that this makes a huge difference within the, I mean, if we would have put a very high carbon price, it decreases the temperature with almost 0.5 degrees.
Mm-hmm.
And now, as you see now, as we set now, we're only 0.1 degrees from this gap that we want to be in. So between 1.5 and 2 degrees above pre-industrial levels. And then we have the natural gas. Doesn't make a huge difference to tax this. We have now increased the carbon price slightly. And then we have this new zero carbon breakthrough, which for now doesn't make that big. Since the primary energy usage has sort of phased and planed out. So it's more in regards to what kind of energy we use, I would say, that we're now. So what do we feel regarding the carbon price? Should that be the final set? We have it now at status quo at 2.1. Any thoughts?
Maybe we could also try decrease deforestation.
Mm-hmm. Yeah, let's try it. Yes. So we do highly reduce deforestation. I'm working a lot with the extreme, policies right now, but I think that's best.
Yeah.
We have industry emission is of course also linked to EnerMan regarding both energy efficiency and also what kind of energy supply we have. Where does our energy come from? What is the sources? So we can see if we highly reduce methane and other gases, for example, for the industry emissions. This is also more related to, it's not CO2 per se, but it's a lot coming from, for example, fertilizers and nitrous oxide, methane, etc., from the food industry. But still, so
Hello.
you saw this. Yes.
Merhabalar, ben Selçuk, Latro Kimya'dan aradım.
I guess that was someone who forgot to unmute or mute. Okay, but now I would say we're
it's
1.7. Yeah. Okay. Are we all satisfied with this policy?
What about afforestation? Like, can we just also try? Do we still have time?
We're moving back now, basically, but we can see that a highly afforestation makes pretty
slight difference. Yeah,
And
but some parameters were definitely more important, like the carbon removal, technologically, also the taxes in coal. Definitely some are of higher impact.
Yeah. We have here, I just want to show you also for the afforestation. Now we have some technological, but you see here for the afforestation, the green one, if we highly growth this carbon removal through afforestation, it's circa twice the area of India that we need to plant in form of trees. So it's a huge part, definitely.
Okay.
Okay, but then we have our, now we're going to move back, but we have our policy. So I will present this to you. And we'll see if we move back. Thank you, everyone. And I'll see you in the big room.
Okay, I will check
Thank you.
the other room and
Yeah.
merge it.
Oh, we have
Thank
a
you.
question here from, no? Did we have a question? No, he moved. Okay. Thank you.
So
Panagotis, did you
sorry.
have? Yeah? Yeah.
Yeah. Well, it's not a question. It's
Yeah.
I don't want to be pessimistic, but this tool, it doesn't take into account that there is something that's called economy. And okay, unfortunately, nobody will invest this amount of money to remove coal or oil or whatever, because it will take 30 years to do it. So it is good thought, but I don't think there is enough capacity in the people that have the money to do it.
No.
So okay, it is from a policy point of view good to do all this, but from a practical point of view, I don't think anybody will follow this kind of policy. I understand it is okay. It is okay, wishful thinking, but I think there are other ways of incentivize the use of energy, like the ones that we are experiencing, very high cost. So the people will be forced to do it.
Yeah. But what would be, because I mean, is this in regards to the tool as such, or just in regards to how we tackle the climate change?
No, the tool is making an assumption that everything is done without calculating the cost or what people are used to. There is inertia in the system.
Yeah.
I don't think we can easily persuade someone to throw away all their cars.
No, definitely
Easily.
not. No.
So,
and I think, I mean, the tool is much as
yeah,
but
we have electrification at 100%. Do you have any idea what will take to have an upgrade in our electricity network to be able to fuel all of these electric cars? It's not possible. Technically, it's not possible. If nowadays we have 5% of intrusion in electrification of cars, and the grid is especially at the edge of the grid, it's at the edge of failing. So okay, I think the tool is sorry.
And I think, I mean, of course, this is I mean, the tool as such and the things you can look at in regards to all of these questions, and also financial parts of all of this are, of course, bigger in the tool as such. But I think also it's also made to kind of create the view of how big the work is that has to be done, you understand? So that, of course, it's not as easy as just pulling a slider to highly incentivized. But yeah, that there's a lot of work to be done, but I agree, of course. I think it's also interesting to see also what then if it's things in regards to electrification and energy efficiency as such, or if it's a lot of just forcing out energy supply, for example, that uses a lot of carbon, because of course different people have different views on how this can be feasibly possible, depending on where you come from or what industry. So, but it's a very interesting input.
Nilay is here. Yeah.
Nilay, we can terminate the breakout now.
Yeah.
He will combine 2 rooms.
Sorry?
He will combine 2 rooms soon. She's waiting for the other room's conversation.
Oh yeah.
Okay, because I think the other group is ready as well. Yeah, okay.
Okay, no, perfect. Okay, thank you, everyone.
Thank you.
You can increase the energy efficiency of buildings, but reduce deforestation, reduce methane gases all from land and industry.
Okay.
And increase energy efficiency of transportation. I'm guessing anything that you increase that has to do with energy efficiency or that reduces carbon emissions is gonna have an impact on your temperature. So if you do like a combination of all of them, you're gonna see a better result than the 0.1 that you see just by changing the renewables.
Let's start by your first suggestion about increase of energy efficiency in the buildings and in the industry sectors. Here you can see a significant impact, a drop of 0.4 degrees Celsius. Also, you see clearly the reduction in the energy use because we are getting very, very efficient here in buildings and in industries for the same amount of energy which was used before we achieve even more. Yeah. And if you combine this energy efficiency with things like electrifying the sector, you can also even achieve more. For instance, the electrification of buildings and industry is clear when you are using a boiler at home, for instance, and this boiler is using fossil fuels. If you electrify it, you use an electrical boiler. Okay. I think you also talked about deforestation, right? Reducing it. If we reduce deforestation, it means we stop cutting trees, cutting the Amazon forest or the tropical forest to plant things like palm oils or palm trees oils and so on. Here, the change is not significant. It's 0.1 degrees Celsius. Not as significant as if we look at energy efficiency in buildings and in the industry sector, but it's still, as I mentioned, every 0.1 degrees is very important. You mentioned also methane reduction. We could look at that. I also assume, or I think the reduction of methane and other gases, mainly in industry, has a significant contribution to temperature, and also the simulation here shows it. Why? Because the methane is a very potent, a very strong greenhouse gas, and if we reduce that, temperature will drop. Yeah. In this tool, you can even click and see what do you mean by reduction of methane. Things like the semiconductor industry, which uses very complex F gases, very strong greenhouse gases, or for instance, in agriculture, especially in raising cows. Cows are behind a high share of methane in the world. Okay. Any other policies?
Excuse me for interrupting for additional reasons, but the colleague of mine, Panagiotis Alifragis, is on the lobby, cannot join either of the two groups. Could you please accept him? That's what he
Let me see if I can do it.
Okay.
Because I'm not the organizer. Nilay is the organizer of the teams, and she split the people.
Sorry for interrupting, but also I have my meeting chat inactivated, so I don't know.
No, I think I don't have options to add any person. Could he contact Nilay?
Okay.
Okay. So let's continue our policy making and testing these policies on a simulation. We have, I think, 7 minutes to build our policy. We're still above the targets of the Paris Agreement. We are at 2.4 degrees Celsius. So what do you think, what are the other policies which we want to test here? Any thoughts? Any ideas? I saw some people writing also in the chat. I saw Fatih was thinking also, I think we did this already with the energy efficiency in the buildings and industry sector. Okay, what about carbon price? Does anyone also agree that carbon pricing would be important, let's say, tool against climate change, because the cost of fossil fuels doesn't reflect the harm they do to the environment. We need to tax that. Taxing it will make the energy more expensive. Then authorities and policymakers need to think of how to use these carbon taxes to make some subsidization programs for poor countries, poor families, to avoid things like energy crisis during winter and people freeze in winter. Any thought about that? We have 5 minutes. Should we move the carbon price slider?
Yes, I think we should. It's a technique that it's okay. To increase the price.
You can also set the price of carbon if you want. You can, for instance, test with $100 for each ton of CO2. You can clearly see the significant impact which this policy have. It will clearly reduce the usage of the fossil fuels, which are very carbon intensive. You see coal or oil, gas, their usages shrink. Okay. Also, we see here on the usage of the emission of greenhouse gases is also dropping significantly, which then in turn contribute to the decrease of the temperature. Okay. If you want to explore also the impact of this on other KPIs, you can look at things, the cost of energy, for instance. You see clearly the rise of cost of energy. What does this mean for households, for instance? How will the households be, let's say, able to buy their energy for the winter, or if in summer, are they going also to be able to do that for and not die in the heat waves? This is a question which policymakers need to think about. And also how to use the revenue which is coming out of imposing this tax. You can look at graphs like the revenue graph here. So from this carbon price, you see that there will be some revenue. it reached up to 3.3 trillion US dollar in 2032. What's going to be done with this money? This is also a question for the policymakers in order to reduce the impact of the rise of energy costs on things like industries, like households, and so on. Okay, so we still have 1.1 degrees. We have 2 minutes to go until we are back to the main room.
What about?
Hmm?
What about their energy?
I don't hear you well, sorry. Could you speak up? I don't hear you well.
Okay, I don't know.
Now it's getting better. Could you try now?
Yeah. What about playing a bit with nuclear energy? I don't know.
With what? Sorry?
Nuclear energy.
Okay. Would you like to tax it if we go in this direction, or subsidize it? There is controversy about nuclear power, but now with the energy crisis, I see some countries are extending the lifetime of nuclear plants. This would be the direction of subsidizing this nuclear and building new facilities to overcome the dependency on fossil fuels. And as you can see here, with subsidizing of nuclear power, we reduce the temperature increase by 0.1 degree Celsius, and now we are within the climate goals or the climate targets of the Paris Agreement. I think we can do more if you want. We can also do other policies. You can test electrification and energy efficiency in the transportation sector, and so on and so forth. But I think for us, for the activity of this ice breaking and warming up activity for the workshop, I think we achieved the goal. We will be asked to join again, I think, the main call. We will be automatically brought to the other call by Nilay. I see Arslan is raising their hand. Is there any question or any wish?
Yes.
Yes.
Hi again. My name is Alp Arslan from Başlasın, Turkey. I just wanted to make a comment on the carbon prices because there are some extra issues about that issue that might help to your simulation in this regard. I believe that carbon price parameters shall have sub-parameters because if it remains below a certain price, industries might prefer to pay and ignore it. If it remains above a certain limit, industries might start making pressure on policymakers, and policymakers cannot ignore this pressure because industry cannot stop. This is an issue because the targets about reducing CO2 footprints and the technology levels which can be used right now around the world are not matching each other. If technology goes with this speed, we will not achieve our carbon dioxide limits. So when we continue about that carbon price regard, and if the carbon prices remains in a reasonable limit, then industries may start asking about questions or how these carbon prices or taxes, no matter what it calls, where these taxes or prices are going. If you use that prices for the topics which are not related directly with the atmosphere or environment, then industries might start doing pressure on the policymakers again. So I think these sub-parameters shall be evaluated or considered in different way, because this directly affects the decisions of the industries or their compatibility with the environmental aspects or the carbon prices. That's what I wanted to.
Yeah, I completely agree with you. I think it's not there is no silver bullet about or one solution that could fit all. I think this is what's also behind the complexity of coming up with these global policies. And in each summit of climate change, there are intensive discussions. And in these tables or in these round tables, the complexity is also when you have emerging economies from one hand, and also advanced economies. You have poor countries and also rich countries, where if you talk about imposing carbon price, how expensive should it be? This question is also not easy to answer, because we have different levels of incomes globally, and it's not easy to find a reasonable price. Yeah.
Exactly. And I kindly recommend you to make some research at industrial level by asking questions to the correct persons, because in overall, in minds and in hearts, we all love environments and want to protect the earth and atmosphere. But when it comes to pay some price for that, these situations may change. This situation, actually, this point creates the difference between academic studies and the reality. So in order to bring an efficient solution for your project goals, I just kind of recommend you to make some research about that issue by just talking people and collecting answers. Thank you very much.
Thank you so much. Yeah. So this activity was an icebreaker activity. It's not the carbon price topic is not directly part of the EnerMan. EnerMan focuses on energy efficient manufacturing, but we tried with this simulation tool to give you an experience of how energy efficient policies like the one we looked at in the industry sector or in the building sector, in the transportation sector, which impact they have globally. You know? So in the future, imagine if the outcome of EnerMan is exploited on a global scale, which impact it would have. We saw that from the simulation, it has a significant impact, because the buildings and the industrial sector accounts for a very high share of the greenhouse gas emissions.
Okay, if it is okay for you, I'm merging the rooms and continue the workshop.
Perfect. Thank you so much, Nilay.
Okay, great. Abdo, are you back? See where Abdo is. Okay, then I suggest we're waiting for Abdo. I think he's on his way in. But I will start, then I can start from our group's side, our climate policy. I will very shortly present this. We managed to get within the 1.5 and 2 degrees Celsius increase from pre-industrial levels. What we basically started with was to highly tax the coal supply, following a highly subsidized renewable supply. In the spirit of EnerMan and energy efficiency, we highly increased energy efficiency in buildings and industry, and also highly incentivized the electrification in buildings and industry. We discussed a bit around the no zero carbon breakthroughs, as well as bioenergy and carbon price. We decided to highly subsidize the bioenergy. Then following land and industry emissions, we highly reduced deforestations. We went a bit outside this energy supply and transport, buildings and industry. We highly reduced the deforestation, highly reduced the emissions of methane and other industry gases. In following spirit of energy efficiency, we highly increased the energy efficiency within transport and electrification. I would say that the buildings and industry energy efficiency made the biggest of difference here, as well as the electrification. And then, as one of the final points, we implemented a high growth in the technological and the technical carbon removal technology. And this is basically our policies. If we have no questions, I say Abdul present theirs.
Okay, thank you so much, Stina. I share my screen to show how our team managed to keep the temperature rise within the Paris Agreement. Do you see my screen?
Yes.
Yes, we can.
Okay.
Yes.
Good. As you see, we managed to keep it within 2.0 degrees Celsius. We could do more. We didn't move all the sliders, but our policy focused on subsidizing the renewables, making them gain the competitive advantage over the fossil fuels, which are cheap. We also subsidize nuclear. We have we impose carbon price, and we saw how significant impact this has on the reduction of fossil fuel energies. Then we moved to the energy efficiency, and we did apply a policy on the buildings and industry sector. We increased the energy efficiency of the sector, and we also increased the electrification. This also contributed to a significant impact in the drop of the temperature, because the buildings and industry sector account for a very high share of gas emission. We reduced deforestation because we believe also trees can help in the absorption of the CO2 and other greenhouse gases. We reduced methane and other gases. Here, methane is a very strong greenhouse gas, and by reducing it also, we achieved a significant drop in the temperature. So that's briefly what we discussed in the team, and I'm glad to that we reach also the goal of 2 degrees Celsius. I think that's it from my side, and back to you, Stina, to continue the workshop.
Okay, thank you, and thank you for this. We will now move to a bit of a break, so we'll do a 15-minute coffee break. So we can be back here by 10:35, a bit below 15 minutes, so we finish on time. Thank you very much for this first part, and I'll see you at 10:35. Okay, so we are back. It is 10:35. I hope everyone enjoyed a bit of coffee break. We will directly move on with the schedule, so we fit the time. I hope everyone is back. Can I get some yes or some raised hands to see that people are back overall?
Yes.
Yes.
Back.
Okay.
Yes.
Amazing.
Yes.
Thank you. Then I'll assume we are all back. Let me share my screen. So now, moving on in the agenda, we have come to the EnerMan key Rs and the key exploitable results of the EnerMan. This will be presented by me and the technical work package leaders that will give an update on the current situation of the results. First of all, I want to explain, because this is a lot of terminology used within the EU Commission in this Horizon 2020 organization. So as Abdo mentioned earlier, exploitation in the way it is described and talked about in the EU is about making use of results and making sure that the project lives on and is viable beyond the project frame, and that a part of that is establishing the key exploitable results. And the question is, what is a key exploitable result then? So we have results as described by EU is any tangible or intangible output of the action, such as data, knowledge, and information, which are generated in the action, as well as any attached rights, including intellectual property rights. So this result is anything, whatever their form or nature, and whether or not they can be protected. So it's anything that comes out of a project, basically. And then these key exploitable results then are the main interesting results which have been selected and prioritized due to their high potential to be exploited. This means, as mentioned, to make use and derive benefits downstream the value chain of a product, process, or solution, or act as an important input to policy, further research, or education. So that's how it's described, a key exploitable result, a key ER. The key exploitable results of EnerMan coming from us, from the exploitation activities, the four, so to say, major ones, and three planes and the package solution are these three building blocks of the EnerMan, so to say. So we have the EnerMan production management system, the data collection system, the energy aware digital twin system, as well as the package solution and the EnerMan product as a whole. And this was decided through the process of the exploitation activities, and also for the first exploitation report, as Abdo mentioned previously. For this final exploitation report, as well as the finalizing, so to say, of these and defining, we found a need to define and characterize these key Rs, also through the project advancement and also potential developments that might be occurring, or of course occurring within these planes. So we conducted a survey, and it was created and focused on degree of innovation, exploitability, and impact on the thoughts of the EU Commission. And this, we acquired some results and analyzed and defined through a list of criteria. So this criteria that also will be presented in this final exploitation report is in regards to innovation, benefits, and technical outcomes, commercial and economic outcomes, process and employee management impact, environmental impact, and then possible tangible or intangible outcomes of the key R, and if any IPR is included in the outputs. And for these key Rs of EnerMan, as you see this picture you've seen quite a few times, we will have some input from the technical work package leaders in regards to these four parts. So we'll have Apostolos Fournais from work package 2 for the industrial data collection system. We will have Kostas Kalogiros from the EnerMan production management system, Sven Spikerman from work package 4 for the digital twin, and Panachotis Katrakazas in regards to the package solution as a whole. So I will present, and they will come and present a bit in between. Just another reminder of this live Q&A. There will be possibilities as well to answer questions all throughout, of course, but if you think of anything, feel free to post. We will move to the first one. So this is the industrial data collection system. So industrial sensors collecting data from various sources inside the factory and aggregating them into data aggregation points. And these results will then be fed at real time to the EnerMan cloud level to extract then further holistic and systemic energy consumption results on the whole production line chain in the process. And the innovation and benefits I'll look through here. It provides the possibility to improve research activities in DL and ML granularity and accuracy of data, and enables the management of large amounts of data through a high connectivity between the data system and further parts of EnerMan, intelligent, holistic, and trustworthy. Regarding the economic impact and commercial and economic outcomes, standalone, it's not considered to have a significant economic impact, but as a data collection tool, it considers to help greatly with analyzing and decreasing energy costs by optimized energy planning. The process management impact is intermediate to high, always this easily collecting data is a great help, and the employee management impact is considered low. The environmental impact is considered intermediate as a tool for sustainable improvements in energy consumption, as the tool is helping further the EnerMan system, but as standalone, it doesn't have any tangible environmental impacts. And possible outcomes of this could be PhD on the topics. We have things in regarding internet, IoT, and these further cloud functions, as well as further products developed and scientific publications. And for this, I would want to give the word to Apostolos Fornaris from ISI.
Hey, hello everyone. I hope you can hear me.
Yes.
Okay, so I'll try to make a small presentation about the work package 2 data collection and EnerMan data collection control plane design. The idea here is to so do you want me to share the screen, or you do the?
You could share the screen if you want, if it makes it easier for you.
I would prefer that, yes.
Yes, then we do it like that, of course.
Can you see my screen?
Yes.
Okay. So the work package 2 of the EnerMan is about is meant to provide four different, let's say, objectives, sub-objectives or goals.
Can you put it in presenter mode? Sorry. Yeah. Okay, perfect. Thank you.
Okay.
Yes, great. Thank you.
The idea is to create an edge-based, an edge level of the industrial IoT architecture type of device that is going to process data, collect data, pre-process data, and analyze them locally before forwarding the outcome to generate a global data collection mechanism, which is designed as the big data analytic engine of EnerMan. So the goal is to be able to do that as fast as possible, collect the pre-processed data as fast as possible, and as close to the source, the sensors and actuators as possible. So we have need to create hardware-assisted accelerated functionality so that we can process data as fast as possible, and also reconfigurability so that this is not static, but rather has a high level of flexibility in order to achieve this high, almost real-time response time to what is being processed. Because we have some software agents in that edge platform, which we call EnerMan Intelligent Edge Node, which is performing intelligent operations using processing practical diverse sensing modalities from various different sensors and extracting meaningful answers from them. We also complete the actuators control configurations. And the overall solution is meant to be protected from data security attacks, from data attacks, so it has that security, as well as is meant to provide high level of trust in the overall process. So in the next few slides, I have some of the key, let's say, results of the Work Package 2 effort. You will see several tables here with some of the results. So on the right-hand side, you can see the EnerMan Intelligent Edge Node execution environment, which is meant to be designed so as to be as flexible as possible. For that to be possible, we have a heterogeneous, we have followed a heterogeneous approach, which means that we can deploy applications at the software level, at the hardware level, at the hardware software co-design level. For that, we use a multiprocessor system on chip embedded system that also has embedded in the system on chip and FPGA fabric, so we can deploy software on the applications on the software using the ARM Cortex-A53 processor on the GPU of it, or on the FPGA fabric, or that's the most likely case, a combination of these different capabilities. However, since we need to create applications that use different programming languages and different tools, the heterogeneity is extended to be able to provide at the execution layer or application layer several different ways of downloading, executing an application. So that's why we have containers. That's why we have a dedicated EnerMan application backbone, which is able to communicate with the drivers of the kernel of the Linux system on the board, so that it can download on the FPGA fabric specific hardware software co-design applications for the hardware, of course. And of course, on top of this is wrapped up in a highly secure framework. So we are able to communicate with TLS 1.3, but not just the typical TLS 1.3 version. We have a quantum safe TLS 1.3 version, which is the next big thing, let's say, in security cryptography world, protection against quantum computer attacks. We're able to provide multiple communication protocols. So in order to be able to collect data from various different sensors that can be deployed that are deployed in the factory, for example, using Modbus, using MQTT, using Ethernet, using Wi-Fi, BLE, and many different protocols, industrial mainly protocols. For that reason, we have multiple communication interfaces and the relevant network stack support. And in order to be able to configure this edge node remotely, we're also able to have the remote configuration registrator and the general and the appropriate backbone in the client at the end device, at the edge device. So we can download remotely an application, run it, and collect the result without actually need to connect to the device itself. And you can see here the process of how to use the execution environment. You can have an algorithm. You can process the algorithm and do a profiling of the algorithm, find out which is the part that needs to be accelerated further, the bottleneck practically. Then you accelerate that using hardware, and you have a hardware software code design application, which you deploy eventually on the EnerMan edge node to keep the computation delay as minimal as possible. And we have software configurability using the Dockers or the Python libraries that are installed in the execution environment, or you can have hardware configurability deployed to download something on the FPGA fabric. The sensor view, so the data collection and processing view. So you can have a collection of data either from the storage area where a specific industry collects its data. So if there is a constant supply of files in this specific folder, we have our own data collection daemon that identifies when new data arrive in the storage area, picks those data and sends them to the edge node to be further processed. The other approach that we can collect data is through our own EnerMan sensor. So this is for data streams. So when you have streaming data that are not collected as batches after a period of time, let's say of a day or a week or so, but you need a streaming of data collection process, then you can use our own EnerMan sensors, our end devices which are connected to the various communication interface that I just mentioned, to the edge node. And of course, all those data that are being collected are practically pre-processed at the edge level and forwarded to the cloud level or system level of the EnerMan architecture, where we have the big data analytic engine that collects and data from the whole factory. So here we have at the edge node also a data harmonization module, which is able to collect the raw data from an industry and transform it, harmonize it in the appropriate format to be fed appropriately to the EnerMan platform. Apart from that, data that are being collected are, for those data, we have some intelligent operations that are taking place at the edge level. Practically, we have created a federated learning based solution so that we can increase the accuracy of the intelligent operation outcomes, also to retain privacy, as well as to handle the distributed computation and the diverse modalities that each edge device may collect data that each edge device may collect. For example, specifically, we have an example of this server client federated learning usage, where we use energy consumption predictions on the local data. We're using deep learning models for that, as well as anomaly detection, deep learning anomaly detection for specific problems. And we're tangling at the moment with the machine health status monitor problem, taking into account that a machine that is running in a faulty state has a significant impact on the energy consumption of the machine and eventually to the overall factory. We also have an imputation mechanism when data that are being collected from the pilots have missing values. We are able to complete those missing values with trained data and continue and fill out a full data set to be used by the EnerMan platform. And this is from the control view, the same our solution. In this sense, we have two different control mechanisms in order to control, first of all, the EnerMan edge node itself, so configure it. So for example, for the intelligence that we have on the edge node, we can update and optimize the deep learning models using the federated learning paradigm. We can, when you have different types of data coming from the pilot side, from the energy, from the infrastructure, from the factory side, and then you harmonize them differently, then we can update our harmonizer remotely and get a new, an updated harmonization process to fit the EnerMan format. And of course, any other new application that we want to send to the edge node, to execute at the edge node, we can do that remotely using the hardware software co-partition, co-design applications that we can deploy again remotely using the remote orchestrator. And the second type of configuration that we can have is to use configurations that are chosen with the help of the industrial administrator by a DSS, a decision support system that helps the administrator to choose a configuration for the various devices within the industrial factory to optimize energy consumption. So these kind of configurations are sent to the edge node, and following some specific strategy that is being we can using an ontology solution, we know where we're able to know where exactly the actuators are placed and where we need to send the configuration to reconfigure those actuators, or if that's not possible, to inform the appropriate human personnel that is handling the reconfiguration of the actuators within an industrial plant. And this is the overall dashboard of the EnerMan edge node. You can see the various, this is just an overview of how this looks like at the moment. Logis and graphs that we have set up at the moment. In more detail, some of the applications that we have installed on the edge node. So we have this federated learning server and client infrastructure to communicate between the federated learning server and the clients. We have the energy consumption prediction, and you can see an example here of the predictions versus the actual values. We implement those things also in hardware. So we have a hardware accelerated deep learning model for energy consumption prediction. We also have a hardware security token that is able to handle all the security mechanisms with hardware acceleration for the security primitives that are involved in it. That also supports the quantum safety LS 1.3, and of course the harmonizer, which is harmonizing the data to the EnerMan format. And again, regarding intelligence, we follow, as I said, the federated learning server client paradigm. So we have, we assume that we can have edge devices, clients practically, that either have the same data values, each client has the same data value, or we can even have clients or edge devices practically where each of them has different values, different data values, and all of them collaborate to create a highly accurate and trained deep learning model, which is aggregated at the server level and forwarded back to the client.
Apostolos, sorry to interrupt.
Yes,
but could you briefly conclude in 1 minute, because we have the the other key hours.
Yeah, and this is done in a cluster-based, apart from traditional federated learning paradigm. Of course, we have anomaly detection using for the health status of machines. You can see here the deep learning model that we're using. Yeah, and this is also an overview of the security architecture of the EnerMan to secure the EnerMan solution. So again, from the industrial data that are being collected, we have the hardware security token at the edge node, and we have also a security gateway at the server side. It's able to protect the overall cloud-based or server-based system of the EnerMan solution. Yeah, I won't go into more details, which more or less covers everything. So, of course, Work Package 2 is finished, but we still want to do some more things. For example, merge some of the solutions with the overall EnerMan platform in a better way, integrate it, fine-tune the solution for various industrial sites that we have in the project, and of course disseminate the Work Package 2 results. Thank you for your time. Sorry if I took a bit more than necessary.
Thank you, Apostolos. Do we have any questions to him now directly? Otherwise, we'll move on. Any questions? Then I remind you, of course, of the Q&A where you can ask questions as well. Then thank you so much for this. We will move on with the EnerMan production management system. So that collects data from various sources and processes them and visualizes them to structure a unified energy consumption viewpoint, where the benefits were answered in this survey as optimization of the production process and energy consumption through decreasing and improving energy usage based on demand for different industrial scenarios. The commercial benefits include increasing the demand for increase the demand for digital twins and therefore further support of the digital twin EnerMan key are. The economic impact on industry and end user is high due to proper production management and planning for reducing energy and operation costs. The process management impact is considered low to intermediate. Employee management impact is considered low, and environmental impact is considered high when considering, of course, that the goal of this key R is to achieve a production process planning utilizing a minimum amount of energy and with a maximum degree of green energy. Further topics and tangible and intangible outcomes, PhD thesis even here on production management, further research, further new products developed, scientific publications, and etc. For this, I will give the word to Kostas, and then for the more simpleness of it, I will ask you to share your screen, Kostas.
Thank you, Stina. Yeah, of course, just a moment. So hope you can see my screen, right?
Yes.
So, hi all, thanks for joining this first EnerMan exploitation workshop, especially the external participants. So this session is about the industrial management system. I'm Kostas Kalogiros from IGSIT Research. I'm a research and innovation manager, and we are experts on data visualization, analytics, and security. So the industrial management system aims at supporting industrial users in obtaining sustainable energy management. And this is done in several ways. Probably the most important ones is by identifying and reconfiguring energy wasteful processes. So this is done based on data, sensorial data, and other info that we get from the system that was the EnerMan Edge node that was described before by Apostolos. And we are also supporting end users by reacting on the increasing volatility of electricity prices or other energy sources, or to power outages. And in that way, we reduce the operating expenditures. We allow to have reduced downtime or better reputation due to more eco-friendly processes. We see here that the EnerMan industrial management system is composed of 4 main parts, and we'll briefly go through each of those. And it interacts with the industrial data collection system that was proposed, that we described before by Apostolos, as well as the system analysis and prediction engine that will be soon described. And we not only retrieve data, but we also propose actuations, and this was also described by Apostolos before. So the first part of the EnerMan industrial management system is the big data analytics engine that is right at the heart of the EnerMan architecture. So you have already seen a similar version of this diagram in the presentation by Alessandro Zanella before. The big data analytics engine provides robust data management pipelines for collecting and serving data, as well as analytics, both from the industrial data collection system as well as from the system analysis and prediction. And it also provides a large library of machine learning models for data preprocessing, for example, for missing values imputation, as well as for discovering trends of increased energy consumption, anomalies, as well as what are the main drivers for these trends. And we already have a very stable version of the big data analytics engine right now, and we are working on to adjust whatever is needed for supporting the pilots. And you can also see some of the some graphs regarding the models that can be supported. If we move on to the industrial management visualization system, this is the main dashboard for energy managers as well as non-experts for interacting with the EnerMan system, and it provides intuitive visualization of various energy sustainability key performance indicators. This, of course, includes energy consumption, energy cost, or the environmental footprint, as well as data streams that can be either internal or external. And we can also have data about the historical evolution of those KPIs, the current values, as well as predictions. And we already have a stable version for the industrial management visualization system. And it has been adjusted to several pilots' needs. The third tool is the virtual and extended reality tools that is more targeted to field workers, and this boosts situational awareness. So it provides a virtual reality or extended reality visualization of the status of an entire area. And we can see, for example, the total power consumption or some alerts regarding the system operation, some visual aids regarding the tasks that are to be performed by the field workers, or any notifications about imminent dangers. And regarding the VR feature, it is aimed for supporting training of employees. And we already have a mature version of this technology, but this is also under development, and it will be soon released in 2 months. And last but not least, we have the intelligent decision support system that you can see on the left-hand side of this figure, and it provides decision support to energy managers for optimizing the equipment operation and the industrial processes. And there are 2 main features involved. The first one is to select or propose the most appropriate control loop to be sent to the industrial data collection system, or it offers optimal production schedules that are taking into account several objectives and constraints. For example, we can see here some schedules, some job schedules for different machines, and we also see here the price evolution. And we, for example, see here that there is a spike in the price, and if there are if the cost for delaying some jobs is very high, then we see that we still perform some production even though the prices are very high. But if this delay cost or penalty cost when we delay some jobs is reduced or low, some of those jobs are shifted in time where the prices are lower. And again, we already have a mature version of the IDSS, and it's being updated so that we can support additional features such as interdependent jobs. I think that's all from my side. So if you have any questions, I'm happy to take.
Okay, thank you. No questions. We'll see if something appears. Thank you, Kostas, very much for this presentation.
Thank you, Stina.
No questions in the Q and
okay.
In the Q&A.
Then we'll take that as everything's clear. Moving on, we have the EnerMan Energy Aware Digital Twin System. So here it is using this collected data from data collection plane and simulated data to create this digital twin of the factory and the process. And this, of course, benefits possibility to try different strategies and identify how the changes in the process impacts the production and energy sustainability, visualizing different results before implementing in line with Industry 4.0. The economic and commercial benefits are considered high. It allows potentially greater energy savings and process efficiency by being able to visualize and assess different strategies virtually before applying them to the process. Also Industry 4.0. The process management impact is considered high due to these benefits in this commercial already named, and the employee management impact is considered low. The environmental impact is considered high. Overconsumption of waste and energy can be decreased and make processes more energy and time efficient through proper investigation and well-grounded research and visualized decision making. Further tangible and intangible results, of course, PhD thesis on these topics as well. You have the digital twin technology, the Industry 4.0, 5.0, production, energy aware production planning, etc. Further research, further new products developed, and scientific publications. All these potentials are there. And then I would like to give the word to Sven Spiekerman.
Yes, thank you very much, Stina.
Yes,
I think I will also share my screen real quick.
Great.
Yeah, welcome from my side as well. My name is Sven Spiekerman. I'm going to present you the status that we have in Work Package 4, the EnerMan System Analysis and Prediction, which, as mentioned a couple of times, deals a lot with digital twins. It's important to point out that I'm presenting obviously some joint work results. A lot of people, a lot of institutions have participated in that. There are a few names listed, and that's not even complete. Just to have that in the back of your mind when we now will consider the collection of digital twins and models. Yeah, the modeling activity has two focus points. One focus point is a simulation. The other focus point is a prediction side, prediction engines, and we have quite a few models that emerged out of this activities, and I will give you, let's say, a real quick overview as these 10 minutes will allow. This is the formal stuff around the work package. I don't want to go into details on that, just so much that there are, apart from the preparation of the prediction engines, as you can see here in the rectangle, rectangle on the left-hand side, apart from the prediction engines and the simulation engines, there was one activity that started the work in Work Package 4, and that was kind of coming up with a taxonomy, a system that kind of allows us to bring the models that we would create into a certain order, into a certain classification. And I copied one slide from this activity. That's this one. Also already, let's say, displaying one of the challenges of the project, because we had to tackle apparently modeling activities coming from the machine level, even from the sub-machine level on the shop floor. So very, very detailed models covering what is going on there, all the way up to workshop or even plant level. And the discussion came up that we would not even stop there, but go to a whole value chain level. And as you can see in the headline, one of the terms discussed in the project was we will not end up with one model, but with a set or a zoo of models that will have to cover this whole chain. And the challenge being that it's not only production processes that these models support, but also use of energy and merging that. So it was kind of helpful having these, let's say, tree of models that we come up with. And I will show you now some examples, and will always try to make clear on which of these levels we are currently active, or where this model is actually then located. And the first one is on plant level, if you want, where one of the challenges came up from the end user partner CRF in the project, to really have one of their buildings and being able to model the temperature depending on the processes in the building with detailed mathematical models. So that first example being on the factory level, if you want. A second example, and while I talk, I will start the movie real quick. Second example, we move from factory level to the very top level. We also decided to be able to model value streams. You see, we're not even in a single factory now, but above factory where we have like suppliers, production processes on a very abstract level, if you want. That's coming from value stream modeling side, which is an existing state-of-the-art technology, but it typically only covers KPIs in the area of production and logistics, like cycle times, like process utilization, and so on and so forth. And you can see now in the center of the screen that one of the issues that the project was tackling to cover also energy consumption of electrical power, of compressed air, steam, and so on and so forth. So that's one of the, let's say, innovations in this field that we say, okay, we want to merge classical value stream modeling with energy-aware value stream modeling. And it's also important that we're talking about digital twinning, right? We're talking about simulation. So this, what you see now in the movie is just giving you an indication of it's not a static model, it's not a static value stream model, but it's a simulation model that actually is running and can, for example, be used to compare alternatives, different production scenarios, and also different scenarios in terms of the used energy in these processes. Again, this being on the, I just need to wait. Yeah, there you see then also results, dynamic results over the simulation time considered for energy consumption and so on and so forth. So a bit like the little simulation that Stina and Abdu did a bit earlier with us. Right. So being on the value stream level, we now will move down a bit again and go to a factory level. This is from one of the use cases where we would, already in the first half of the project, try to come up with a very tangible modeling activity, displaying what is going on in the processes of partner Stomana, which is in the steel industry. Very energy intensive, of course, melting steel in a couple of furnaces and then transporting this steel with so-called ladles between the different furnaces. And as you can imagine, it's not only a challenge from the material handling side, but it's also a big challenge in terms of use of energy, because you have to maintain apparently a high temperature level in these furnaces. But not only that, you also have to maintain a high level or a certain level of temperature in the means of transport in these ladles. And typically you would consider either temperature in the furnaces or you would consider the transportation cycle. And the idea of the energy-aware modeling here is really to merge both. And just to give you also a quick impression, quick flavor of what is going on there. So this is showing now some of the modeling results where we have also 3D image of what is going on there, the ladle transportation. Of course, a big part of the important things are happening behind these bright and colorful pictures where the calculation of the temperature is tracked so that the model also always knows what the temperature in the different ladles is in the different furnaces is, and what the use of energy, of course, also is. And then next step, next activity, which can be used, well, I guess at the end of the time on different of these modeling levels. We're coming to the prediction part that we also have. So one economic part that was included was a price prediction models for energy prices mainly. Here, some sub-technology, if you want, of artificial intelligence, random forests came into play. They were evaluated and it turned out they would give a good prediction quality. And one of the next steps is now merging these price prediction models with the production models to be able to, let's say, react on the production side to changes in prices, midterm, short term, or long term changes in prices. That's some work that's ongoing now. Of course, and this is then I'm going to come to an end. As in the other work packages, it's not just about the concrete models that we deploy for the use cases, but to have a generic environment. Here, for example, is a generic architecture of the price prediction environment that we have that can be used and invoked in different models. Here is also just as a quick impression, quick glance, the generic architecture that we have for the simulation backend, where at the moment the project partners, but talking of exploitation, then also other partners or customers could use the value stream activities, could use the detailed models to the degree that they are available. And well, also as mentioned by other work packages, still some work to do in terms of exploitation. As Stina mentioned, there are some very concrete ideas already available, but the project for sure will refine that in more detail. And I think that was my part. Thank you for your attention. And of course, I'm happy to take any questions if there's any.
Any questions? No, I proceed, we move on, and I say again the live Q&A. Thank you so much, Sven, for this presentation.
No,
very glad.
The live Q&A.
Great. Then we have, coming to the last part of this presentation, we have the sort of package solution to all of this, and this can of course be interpreted in different ways. And most of the, in regards to this, when the survey was planned, these commercial and economic outcomes, the process management impact and employee management impact, and all of these are of course more to be referred to in the survey way, and the way we characterized it to be referred to as key ERs. But of course, this whole package solution is the complete energy management and prediction platform that optimizes processes, understands base loads, and allows for potential control to improve energy performance. And it could additionally offer possibility for further innovation as it raises from the mutual interaction and integration between these three planes, as mentioned and presented. And for this, I give the word to Panachotis Katrakazas from Work Package 5. Yes.
Thank you, Stina. Let me just switch to my presentation. Just for allowing it. Okay. Thank you.
Thank you.
You can see me as well. Hi, everyone. So my name is Panachotis Katrakazas. I represent Maggioli, and we are the integrators, and I'm the scientific and technical director of the EnerMan project. I'm going to present you the EnerMan integration and cross-layer optimization, which basically is the whole package of what the EnerMan is giving to the community and to the industrial settings. So just a few words about Work Package 5. This is the main integration works that are going to be performed of combining the whole elements into one solution. So these are the general description of the work package and what we have been doing so far. I'm going to present it visually so you can understand it in a more visually friendly way. As you can see, and I don't know if you have seen that figure before, this is the concept architecture of the project. So we have 6 subsystems that all of them comprise the general EnerMan solution. And in terms of the integration aspects, what we will do is combining all these features and modules under one common architecture. The first objective has to deal in order to create the EnerMan Energy Sustainability Aware Digital Twin. And this includes the Big Data Analytics Engine, the Simulation and Prediction Engine, the Intelligent Decision Support System, and the Industrial Management Visualization System that you have seen previously in Work Package 3 and 4 presentations. The second objective is to integrate this with the data collection mechanism, which is the Work Package 2 presentation. And this will also be combined under the EnerMan Virtual Factory, which consists of the virtual 3D factory and the virtual reality or augmented reality toolbox that is part of the EnerMan environment. All of them together are going to be integrated into the virtual factory and digital twin system, which will be the prototype, which will lead to the prototype and the fine-tuning of the system based on the pilots that are going to be testing this environment under their pilot sites. So in terms of the progress that we have been doing, we haven't proceeded as much because this has started pretty early on the project. This is last year. We are on the first 6 months of this work package. We expect most of the work to be completed by the end of the project, which is on month 36. We have presented a preliminary EnerMan prototype report, and we have produced the first version of the integrated platform, which was a partly functional version of the system, showing some interconnections between the modules. And this has also been depicted into these use cases diagrams, where we can see how the EnerMan users can fully deploy the system into the pilots, and then they can use some of the modules, for example, the prediction engine that you can see here and the intelligent decision support system, to provide some monitoring and metrics about the holistic sustainability status and the energy consumption or predictions about the energy costs and the CO2 emissions. And these can all be visualized through the management visualization system and give this information back to the factory managers and the factory floor operators should this be deemed necessary. What we have also done is that we have tried and we have successfully completed the communication between the modules. So as you can see here, these different submodules that I showed in the beginning have been technically validated and identified as far as their cross interaction and communication aspects were concerned. So all of these have been monitored and they were successfully shown. The partly functional demo of the version 0 that I described earlier is basically the communication and version of the intelligent edge node, the big data analytics engine, the industrial management visualization, and the electric energy market price and forecasting modules. All the other modules have already been developed separately. This has not been validated as far as their connection is concerned, but this is the work that is being currently done in terms of the work package 5. So this is where we are proceeding from now on. Another key that we have achieved in terms of the work package 5 and the integration aspect is the introduction and the showcasing of the DevOps culture into the testing principles for the integration process and the use of a process modeling roadmap, where we can identify which models we are going to be using in terms of the integration aspects and how the scenarios can be assessed and optimized through the KPIs and the objectives set in the EnerMan project. All of this will lead into a feedback loop that will update the platform on various occasions. This will be done through the small releases aspects that you are seeing on the left side of the screen. And there will be also continuous monitoring and feedback approach that will lead us to a continuous integration and finally to the EnerMan solution that will be presented. That's it from my side. Thank you for your attention. And if you have any questions, you can ask me now or at the Q&A session later. Thank you very much.
Thank you, Panagotis. We will move on if there isn't anything urgent. There are no questions in the Q&A. I will keep on sharing.
No questions in the Q&A.
Great. I just have to open this. Let's see. Okay. Let me share my screen. We now come to the thank you everyone again for presenting these key areas and giving this insight, this technical insight to the project. We are now moving to the schedule is a bit delayed, but I think we'll manage. We're moving to the SWOT analysis exercise, and for this we wanted to shortly present because the idea of this SWOT exercise is to because we have a SWOT that we've done these past months as from a basis of a SWOT that was made for the proposal of the EnerMan project, and we want to use this time a bit to discuss with you in this workshop, so internal and external partners of the EnerMan regarding this SWOT analysis. And I will give the word to Rita if you can shortly just go through these the SWOT that has been made, so the first points.
Yes, thank you very much, Tina. So, yeah, I will proceed with a short presentation of the SWOT analysis. So right now you're able to see the overall scheme, and now we are in the strengths. So one that we considered is the fact that it is an end-to-end and real-time data management solution. Then that it contributes to a more environmental friendly footprint and energy optimization. The ability to be applied to any manufacturing domain, so it's customizable. That also it is an AI-based predictive analysis. It's a holistic approach regarding technical, economical, and social KPIs, and the possibility to give the staff knowledge about EnerMan and energy optimization. Regarding the weaknesses, the answers collected from the surveys were that different technologies, it can be a weakness that we need to integrate different technologies. Also, the numerous existing digital twins technologies that are already available on the market, a potentially high time and money consumption on training and adapting to the new tool, and also potential technical difficulties in the implementation, which can also be related to the first point. Then moving forward to the opportunities, EnerMan targets critical and emerging EU markets. Also, the fact that the EU is increasing its environmental policies is an opportunity. The higher energy consumption from the industry sector calls for energy efficiency, cost environmentally wise speaking. EnerMan is also aligned with an industry digitalization and industry 4.0. Also, the higher the cost efficiency provided, the greater the interest to join EnerMan. Can also be an opportunity. And better situational awareness that the managers get by acting as an aid in decision making and training support. And last but not least, some examples of threats are multiple emerging solutions related to energy management, the market competition, the unwillingness of manufacturing operators to adopt new technologies, the lack of financial incentives and risk of long-term financial feasibility, geopolitical risks. Some governmental rules can also be threats, and also non-controllable events like COVID-19 pandemic or the actual war in Ukraine. And this was the SWOT that we came up with after our several brainstorming sessions and also after the survey. And now we would suggest that we play a game in group. Maybe Stina can explain better.
Yeah, so I'll actually just bounce that ball to Nile, because we will be using a platform called Miro, and Nile from Interact is the expert in this. So I will give the word to you, Nile.
Exactly.
Thank you very much. My name is Nila Yörük from Interact. I'm managing partner and I am the dissemination manager of the EnerMan. And today we will execute the SWOT analysis with the Miro platform. I will share my screen to show how it works. Yes, we will share a link with you. And you can easily reach the SWOT analysis. As Anarita showed, we already have some points about the SWOT, and we kindly request to review the added points and add new ones. For this, you can use these sticky notes. Any color except yellow, and you can pick it here and write anything you want as a comment. It will put it and save it. You don't have to add your name or organization, but if you want, you can also add, and we will execute the exercise. Then we will get the comments and discuss on it. Thank you very much. For any problems about access, I will write my email to the chat, and you can reach me for solving the problems.
We will split, I think, into 3 groups, right? Again, we move to breakout sessions, 3 groups. There will be 3 moderators.
Okay.
And we will do this brainstorming together to refine and update the SWOT analysis using the Miro platform, as Nilay explained. The assignment of the group will be randomly again, and we wish there to hear from you, your perspective, your feedback about what do you think these strengths, weaknesses, opportunities, threats to the EnerMan. No?
Okay, I'm generating the groups.
Thank you, Nilay.
Would you prefer, or would you also want me to share it? So share the screen within the group, or do you all want to have it open on your own part?
I have open, so for me it's the same.
Yeah, I also have it open.
Okay, great, great. Then we can keep it like this. Then I guess, so the first question is if anyone has any comments on the ones already placed, or something you agreed with or found questionable in any way. Marco, for example, coming from a big part of the EnerMan project as well. Was there anything you thought maybe you'd find in the analysis that you didn't, or things that seemed misplaced, or?
I'm having an connect.
Sorry?
I'm having an connect.
You're having, sorry?
A look. I'm
Yeah.
looking
Yes, of course. Of course. Panachotis, you have your hand raised.
Yes. The most important concern, at least internally, in my opinion, is that there's a lack of data. That we historic ones and probably the commitment from end users that they should provide as much data as possible to the technical partners. And this was obvious, at least in the that we had, and it's evident also for our side. I understand that it is work package 6, which would be the application of the developed technologies at the user sites will definitely accelerate that. But still, this lack of information could have made us develop technologies that probably they are not exactly applicable. And that's the
So lack of data provided by the end users,
Yeah, because okay, we were developing using requirements that were partially in documents and partially from literature, and we don't know if the developed technologies are really applicable to the use case that we have. So we'll see in the next months. But
yeah. But I guess from the end users,
probably it will. My concern is that if it is the case that there are a lot of asynchronicity between the requirements and the developed solution, there will be more effort that will be required, and then we have to probably move some resources from end users to the technical teams in order to be able to cope with this problem, and this will not be easy, definitely.
But then I guess it's also based on like how much the end users can share and all of this, that kind of becomes a clash, I guess. Or is that where it comes from, you believe? Yeah.
Yeah, definitely.
Yeah.
I understand they are companies and they
of course,
they have internal
but definitely
constraints also, but still.
Yeah. That's also interesting with these types of because this is the first sort of big project, a new funded project like this that I'm active in, and it's, I mean, of course, the sort of wide range of these end users and these companies and also research centers and everything. One comes from different parts with different needs and stuff. It creates these.
Okay, because I'm involved in many years in this kind of projects. I think it has to do with the commitment of the management that they want to implement something. If there is, then usually they manage to find ways, even internally inside their companies, to impose that this is really required. That's so I have been to both types of problem. One, if they really need the one, if they really need the solution, then they are able to impose it. The higher management. That's okay. Thanks.
Thank you. No, great. Thank you for the input. Does anyone else have any input? I don't know all of us in this room. Anna, you're from Urban Wind. That's another EU project, right? Or is it? I see that you unmuted, but I can't hear anything. No. And Francesco, are you from the stakeholder side?
Francesco is from Gradienti now, from Additive.
Okay. Just to make sure I see everyone.
I think the external partner are Anna and the Wagelos.
Yeah. Marco, do you have any thoughts?
See that many things are already written.
Michael Birbas, you're also from the consortium, from UOP. Do you have anything to agree or disagree on within this SWOT analysis? We see now people are adding regarding so a weakness in property and close technology present in the industry that is difficult to integrate. Challenges regarding training could become. Did someone say something? No.
Michael is having a technical problem with his mic. Okay. No,
it's working now. Here we go.
Please. Here I can hear you now. Can you hear me?
Yeah.
Okay. I have problem. I have been thrown out from the Teams.
Yeah.
There will be several minutes before I could enter. So.
Okay, strange. No.
So sorry.
Did you get the link to the Miro with the SWOT analysis?
I got the link. I'm not sure I'm not in yet.
No.
Yeah.
Something else that we have to always take into account is especially for the problem that we are working on, which is price forecasting for the energy markets. Unfortunately, the time is not. We cannot get the real data that are really required, which is if someone will stop providing gas to Europe and at what amount, and what will happen with sanctions to Russia, and so we are trying to forecast something that is there are a lot of external data that are not accessible to us. So okay, the quality of the prediction is not well, it's not very good, unfortunately, because it's not a physical phenomenon anymore.
No. It's affected by so much, yeah. But is this is something that's currently being worked on still within the price forecast?
Yes. We are monitoring TTF prices and CO2 prices and other stuff, but still it could be the case that some really if you ask for a forecast in 15 days and then in 5 days you close the amount of gases go to zero, then you really can't forecast it.
No. Yeah, and political sanctions, of course, are very hard to forecast as well.
Exactly. That's the problem. It's not a physical phenomenon anymore. It's
no.
It's random.
Yeah, definitely. No, but that is very true. But that's so. I guess that's could be sort of both a weakness within internally, but also, I mean, of course, I think for the threats we added. Of course, part on geopolitical risks and all of this, but a threat or weakness could be the ever-changing, and hard to forecast energy prices due to very non-scientifically related and non-predictable outcomes and decisions. Michael, did you have anything to add on? No. They have added now. So we have economic crisis that can affect investments as threats is added, and lack on trust on external actors like EnerMan platform, especially when the requirement is to allowing to close a control loop over cyber physical things. To overcome competition, a clear competition ecosystem needs to be defined. Is added as well. Geopolitical and man-made events, climate change could be an accelerator for the EnerMan solution. This is an opportunity. So it's more people see as a more positive to invest in energy efficiency and sustainably viable solutions. Today's energy crisis may force industry to invest on energy optimization the same, and climate change can accelerate the energy consumption optimization. What is relating to what you mentioned regarding the issue in price forecasting, would you say that that's more of a external sort of threat to this, at least this price forecasting part of the EnerMan solution, as an external part that we can't really, since these sanctions made or geopolitical decisions are sort of outside of the EnerMan, or would you say it could be then considered as an internal?
No, it's not internal.
No.
It's definitely
No.
external, and it is unfortunately we have to take that into account, yes, and probably be able to respond by probably providing some confidence levels to our prediction, which is okay. We can also generate probably some very pessimistic or very optimistic, and then create some because practically the ones that are being affected is the price, because unfortunately the energy markets are highly correlated.
Yeah.
So if there is a high price in the gas market, then this definitely automatically affects the electricity price and other stuff. One good thing is that in the review in the last months is that both Iotis and ASAS are able to also produce some power on their own, which could also make more stable the solution. And this could be something that can come up with the EnerMan, that probably the factories should try to invest in creating probably some self-production, renewable or whatever, to make some basic sourcing. Would be a good idea.
Yeah, to kind of capture those final peaks, so to say, if it would appear.
Yes.
Panagiotis, what about the other thing that we are developing, the production schedule? I think this is also, I don't know exactly what we're talking about, but it's also something very, very useful for someone planning its production and see what the energy cost. I mean, the linking of the energy for cost forecasting to the production planning is also some good tool that could help the various industries to, let's say, arrange their planning along according to what they would like best, to have very low energy cost, like you exactly said, or very green energy or something like that. I'm sorry I've been entered late to the session, so if I'm repeating myself, please.
And one real good strength of the developed tools is that given that we have developed a toolset approach in the production scheduling, we are able to react very fast to any changes. So if, for example, a solution immediately change the production schedule is required, we can generate it in a couple of seconds. So even for very large cases. So okay, it will not be optimal, and this could we could also use some more fancy algorithm to make a, let's say, a more long-term schedule. But for the imminent, for some real big change, then can generate solutions very fast, and this apply to the production immediately. This is very really useful.
Sorry, I didn't hear the it kind of cut out.
So the idea
for the yeah, sorry.
Yeah, so the idea is that okay, if for example there is some failure in the sourcing of energy, for example, 20% or 30% is cut due to some failure in the grid or some inability or some requirement, then definitely the production schedule should be changed immediately. And this requires some very fast, high quality solutions to be produced, and we have this kind of technology inside EnerMan now.
Yeah.
So it is useful, and then of course in the background we can start trying to solve a more fancy algorithm to really find the optimal solution at the background. But the thing is that given that there is not just a single solver but multiple solvers. We can have fast solutions and high quality ones. Parallel.
Yeah.
Okay, that's a good approach, I think.
Is that something? Sorry, keep going.
It's the result of the linking of day-ahead price forecasting or performing in one task and production planning performing task 3. So this will give some, let's say, close to real-time conditions for next day and next hour and so on. Something like that.
Is this, I must ask, when the so how it is this like sort of fast solution, last second, sort of if there's a quick issue, grid issues, etc. These solutions, was that something kept in mind in the creation or in the beginning? Because I wasn't here from the start, but was that, or is that a good sort of outcome of the, or was this sort of, we need a fast decision and solution maker in case of these last second issues? Was that considered?
Well, to find a good production schedule 1 or 2 days ago is useful. On the other hand, we know that there are situations, even not the ones that we experience, but okay, for example, a machine fails. So you have to readapt and readapt your production. And we had that at the back of our mind when we were starting developing, and we tried to create not just a single solver approach, but a toolset approach. Very fast solvers, very high quality solvers. So we can have both.
Yeah.
But just to add to what Takis Panagiotis said, because of the very volatile market, energy market right now, I'm afraid that the day-ahead predictor, the day-ahead planning will be more and more, let's say, prevalent to related to other kind of production plans. I mean, okay, someone will have to plan to plan his products, to plan his production for the next 1-2 weeks. But since this is strictly linked to the cost of energy, and we know how this proceeds, I don't think that this will be very efficient. That's my. That's what I think. So day ahead will be, I think, something will be asked more and more in the next future.
Or even hour ahead, or 15 minutes ahead, or whatever. The energy companies will definitely create some schema that if they impose extra costs, they will propagate them back to the customers. So nowadays it's not the case. Usually they have other kind of more long-term contracts, but it will change. I don't think I don't think they will survive given the volatility of the market. So this will definitely affect the production of industries. So
It might sound funny, but I have asked from the guys that develop the price forecasting engine to add also another factor, which I call Putin factor. When it's 1, you have full gas. When it's 0, you have no gas. So I don't know.
Okay, but that's thank you really for some great input. As you can see, we have about 1 minute left, so not if anyone has any last minute comments. Otherwise, we leave it as this.
Meet the objectives, then this can be indeed realized.
Okay.
So, but again, I think there are indeed some hurdles in this when trying to implement this, because again, there are several technologies to be integrated, and I think maybe another weakness is that there are a lot of data to be taken into account, and this also involves several data streams, either internal and external. There are legacy systems that need to be integrated with, or there are many energy sources that could be potentially used, and we need to keep track of energy prices.
Yeah, that's very interesting, of course. So maybe we can write here. I'm not sure how can I make the letter smaller, but yeah, it's very important, this weakness, for example. Like it's too small now. A lot of data to track and to take into account. It's very interesting. Yeah, but as you said, it's just a simulation, so it doesn't need to be always fully implemented. Yeah, you're right. So yes, and about this one, numerous existing digital twins technologies already available on the market. Maybe if someone wants to participate on this one, maybe Sven, do you have any comment regarding this? Do you think that it will be hard for EnerMan to penetrate the market, or does it have a place because it's different in some parameters? Or I don't know, do you have any comment?
Well, as a matter, I think, as of fact, I think I was the one who raised this weakness. So yeah, that's just how it is. There's a lot of modeling technology out there.
Yeah.
But of course, the project does have some ideas beyond that, as I was trying to explain. And so I don't have an additional risk or weakness to put on top of that. That's pretty how it is. And but the project does give us a nice chance to go beyond that. That's so I rather see a chance or a strength in coming up with new approaches that differentiate from what is already there.
Okay, great. Thank you. Thank you for your contribution. Maybe we can move forward then to.
Sorry, I have.
Yes.
Sorry, Anamita. I was thinking that this is probably not a weakness, because this is not under our control. I think this is either a threat or an opportunity. I think maybe a weakness could be related to the lack of standards for digital twins or something like that. Maybe, not sure. So I'm still trying to understand why this is considered a weakness. Maybe,
no, it's true. Yeah. No, it doesn't make sense, because as I said in the presentation, when it has an external origin, then it should be either an opportunity or a threat. So yeah, it's something that we cannot control in the project. So you're totally right. Let's change it. Maybe we can just copy and paste it, but yeah, sure. This is, so maybe it is a thread, like, for sure, right? I think everyone agrees that it is a thread. Okay. Maybe we can delete this one or put it in another color, like, so that then we can make some comments. And here as well, like in green. Okay, thank you. Then I think we can move forward to the opportunities. So targets critical and emerging EU markets. Also the fact that we have higher environmental policies in the European Union. Definitely an opportunity for this kind of tools to grow. Higher energy consumption from the industry sector calls for higher energy efficiency. I totally agree with this as well, because also with the war now and inflation, everything will be more expensive, and a good energetic mix will be like crucial for a company or the success of a company. Then the fact that EnerMan is aligned with the industry digitalization industry 4.0, it's important as well. This is related to this one, like with the higher cost efficiency provided, then it will be very more attractive to apply to EnerMan, like to have this product. Yeah, the fact that managers get a better situational awareness, it's also interesting, because as it is a simulation, then we're able also we have access to all the energetic costs, and we can have some goals and some objectives for the company. So yeah, I think it's pretty complete in the opportunities. Yeah, some more external opportunities. I don't come up with any. Perhaps we can move to the threats. That's maybe easier. So multiple emerging solutions related to energy management. So the market competition, yeah, we already mentioned this. Then this one, like the unwillingness of manufacturing operators to adopt to new technologies. I think this one is as well a weakness and not a threat. I don't know if everyone agrees, because yeah, it's something so internal and not
yeah, maybe this is related to customers, not only the partners of EnerMan. Yeah, so
true.
maybe it's a threat.
Yeah, I agree. Yes, because
but it is also related to, you know, to the whole context. I mean, the war in the Ukraine, etc., could you know, increase their willingness. So yeah, this is something that may evolve over time.
Yes, it can be a threat, or also an opportunity. Like yeah, because the thing is, like the manufacturing industries, they operate in a certain way, and then whenever something new comes, it's hard to adapt to it and to teach everyone. So it takes time, and it's completely okay if people are not don't feel attracted to the tool. But that's why I think that the price efficiency, the cost efficiency is an strength, a huge strength. Yeah. Then this one is also important, like lack of financial incentives and risk of long-term financial feasibility. Maybe someone would like to comment this, like related to EnerMan, like how the way that it would be financed, and yeah, it can be a problem in the future. Don't know if anyone would like to comment. Also this one, yeah, geopolitical risk, government rules, non-controllable events like pandemic situation or the actual war in Ukraine. It definitely makes things less stable, so it can contribute to improvement and so that people want to have different approaches, but also like when things are so unstable, it may not be so attractive now to have like something like EnerMan in the manufacturing industry. So I don't know if someone wants to comment these are things the contrary. Maybe Panayotis, do you have some comments regarding this threat? Or some new ideas?
This is Kostas again. I think, yeah, the actual war in the Ukraine is probably an opportunity for EnerMan. So, and this is what we put before as an opportunity. So we probably need to make sure that there is no conflict. So to be honest, I don't think or I cannot think of any way that the war in the Ukraine poses a threat. Of course, there is a lot of uncertainty, or the prices are higher, but this, creates a motivation for factories and factories of the future to be better prepared or to be able to adjust their production schedules, to choose more energy efficient devices, or even invest in local production, which again requires an energy management system. So I think this is an opportunity. Of course, this is not a happy situation, but I think it would be a threat if, there was probably a war to escalate in Europe as well, or to have a third world war. Of course, that would be a threat because it would disrupt the economy and our lives. But or maybe it could be a separate point.
Yes, I understand. And I think also here it was meant as well that, for example, with the war, the prices increase, and but still this could represent an opportunity for EnerMan, but it can be harder to implement. For example, the pandemic, the coronavirus it's just destabilized everything, and basically a tool like EnerMan, it wouldn't be so easy to grow in this when the pandemic was in its peak, for example. So I mean, I think they mean like unexpected events, so something that's not so stable. Maybe we can read some other suggestions from others. To overcome competition, a clear competition ecosystem needs to be defined. Okay, maybe not a threat, but yeah, I agree. Let's see, maybe here as well on the opportunities. Climate change could accelerate the energy consumption optimization. Totally agree. It's also sad, but it's an opportunity to to make everything more efficient and to have a better energetic mix. Then today's energy crisis may force industry to invest on energy optimization. Yes, it's the same idea. Totally agree as well. Let's see on the weaknesses. For example, property and closed technology present in the industry that is difficult to integrate. Yes, it's also mentioned here. Challenges regarding training could be overcome by virtual reality. Interesting. It's true. Very interesting. But it wouldn't. Okay, they are like. It's not a weakness, but it's against this weakness. Yes. Let's see. Maybe here in the strengths. What was added? Tackling with security and data sharing. That industry has great concerns for adopting in digitalization. Energy-aware scheduling toolbox approach to BH to generate high-quality solutions in a very changing. Okay, this person is still writing. Yes, augmenting reality technology that can reduce human errors. So yeah, I agree as well. Okay, some ideas are still being written. But it's interesting that we can make it even more refined, the SWOTs, and more correct. So we had here some mistakes. I don't know if anyone has some other comments or ideas. If not, maybe we can give some minutes, like 2 or 3 minutes so that everyone can think about some strengths, weakness, opportunity, or threat to add, like to themselves. Because also when we are only speaking, it's hard to think. And then we will soon as well return to the main room. So yeah, I would say now everyone has the link, so I will quickly stop sharing and everyone can maybe write something. Okay, not so many new ideas have been written. Maybe I will just deal with this one. Okay, let's wait a bit more. If anyone has more ideas or comments, feel free to speak always, please. Okay, we have to wait until the activity is finished. 2 more minutes. So that we go back to the main room and have the conclusion of the workshop.
Nilay?
Yes, I'm here.
Can we have I don't know how to have a individual call between me and you quickly. Could you move me to a breakout, only me and you?
Okay, I will try.
I think for the rest of the breakout, please give in your ideas about the SWOT. What do you think? What do you think of this SWOT of EnerMan? What needs to be updated? What needs to be refined and added to the SWOT? I see already some people are keying in their ideas. Okay, hi everyone. Hi again. I just had discussed some topics with Nilay. I see some people are already providing their input. I think we can basically continue suggesting some ideas. Use different colors, please. We will finish this activity at 12:05, so 5 minutes past 12. There is a timer on Miro, you can see it. It is set to terminate after 17 minutes. Okay, for example, here. Does anyone have questions? Does anyone have questions here from the group, or they're facing some challenges to give their input to the Miro? I see already a lot of people are keying in their answers and their feedback. Please continue to do so. I think this activity is very, very important for the exploitation activities of EnerMan, to hear your feedback from the consortium partners, but also from the external stakeholders is very important for the exploitation activities of EnerMan. We have 6 minutes left. I remind you to continue giving in your thoughts. I think very interesting points are coming in with regard to the opportunities, like how geopolitical events and how man-made events like climate change could help in acceleration of climate policies and environmental policies that then feed into the increase and the acceleration of solutions like EnerMan. Or from the threats perspective, how disruptions like COVID-19 or Ukraine war could represent a real threat to projects like EnerMan and prevent from their exploitations.
last minute for contributions.
Okay, I think it's already done, right?
Yes, I will merge the rooms if it is okay for Yapto.
Yep. I think now we can go back.
Okay, I will get confirmation about other groups also if there is an ongoing discussion.
Rita is also okay. And is Tina.
Okay, thank you. I believe everyone is back, and I hope that this was a fruitful discussion. We had in my group a few discussion topics, so this was good. We will not go through it now because we will do a short Q&A and finish up here, but we will send this out a bit more organized, and so it will be available as a handout of the workshop after, with all these added points to this. But a big thank you to everyone. We will very soon round off. Abdur, Nilay, do you have anything to say regarding this swap?
Nothing from my side, just a thank you for all of you to provide your input about the SWOT. I think it was an interesting activity. And as Tina mentioned, we will share after we organize a little bit the sticky notes which you put on Miro. We make it nicer and we make it available to you as one of the handouts of this workshop.
Yes, thank you very much for all contribution. We are a very open group and we are open for interacting for also other activities. We will repeat the workshop at the end of this year or beginning of the next year. So we will be also happy to see you in the next workshop. If you have any comments, suggestions, anything, we will be happy to discuss, and you can reach us from our emails or from our website, and you can follow our activities from our social media accounts.
Great, thank you.
And to remind also about the stakeholder community, Nilay. There is also the stakeholder community in the website of EnerMan. Please distribute it and invite more people to be stakeholder of EnerMan if they have interest in energy efficient manufacturing.
Yes, we are aiming to engage people from different industries and different groups. So it's important to reach many people. Anyone relevant to this topic can enroll the stakeholder community and participate in our activities.
Great, thank you. I wanted to ask if there are any questions now. Any questions from the participants? Just scream out. Otherwise, of course, as Nilay said, you can contact us via email. You have our email addresses and everything. And for a just wanted to show here for the next steps, at least from our point, is of course, next big is the final exploitation report, and then that will have a second exploitation workshop scheduled in circa a year from now. So please look out for that invite as well, as this Nile mentioned this as well, and you're warm welcome to join. We just wanted to finish off with 2 more quick interactive questions. The first one being, so we can open the Slido again, Abdo, if you can send the link in the chat again. We have then the 2 simple questions of what are your key takeaways from this workshop, and also, since we are having a second workshop, and this is we want feedback as well on all of this, is if you have any feedback for the final exploitation workshop scheduled in a year. So this is anything good, bad, or like if something we should do more of, less of. If you have any feedback to this, this would be much appreciated.
So I activated the first poll. It's now available.
So this is if you have any feedback, then I guess, yeah. The key takeaways, also active. Energy is critical, yes. SWOT analysis. Energy market volatility. Abdul, do you want to activate as well the feedback question?
Maybe we can do it in 3 minutes. Give some more time. I see some participants still typing. We open the second poll at 12:15, and then we concluded at 12:20.
Yes. Perfect.
I see a very interesting comment about energy production planning. I think it's interesting point which reunite the production planning and the energy planning. The production planning has been focusing on cost aspects, but EnerMan is trying to also include this energy perspective into the production planning to achieve sustainability. I also see sustainability importance, no doubt about that. Well, it seems that the feedback is now stabilizing. I see one more participant typing.
Yeah, I think we can open the next one.
Okay, if later some thoughts come to you, please send them to us by email. Don't hesitate to do that. Now I will open the second poll and share also the link. It's about your feedback to the next exploitation workshop. As Stina mentioned, what do you suggest to us to include in the next one? What is the thing that you like the most about the workshop today that you would like also to see again in next year workshop? If you suggest maybe to add completely new part, please do so. Your feedback is very important.
Mm-hmm. Great, we have some demo of EnerMan solutions by one of the pilots, demo of the use cases, more project results, and also achievements that have exploitation potential. I believe it has died down, as well as Abdo mentioned before. Any more feedback or any thoughts that you might have, just feel free to email us about it if something would pop up. And with this, it has died down a bit. We'll see if. But with this, yes, we want to say a big thank you to everyone that attended. It's been a very nice morning, so to say, a couple of hours, and I'm glad about these interactive parts and also presentations from our technical partners and the coordinator. And yes, a big thank you from all of us.
Stina, a suggestion from my side, should we do a together mode group picture like what we did in the review meeting? I think it would be interesting.
Great idea.